Class 12, Wheatstone Bridge MCQs. Question: electric strain gauges are measured by a Wheatstone bridge because A. High sensitivity. B. Low sensitivity. C. Sensitivity is 0. D. Sensitivity has a finite value. Answer: B. High sensitivity. Question: Wheatstone bridge is a AAC bridge, B. High voltage bridge, C. Power dissipation bridge, D. DC bridge. Answer: DC bridge. Medium resistance is measured by Wheatstone bridge, which is a DC bridge. High voltages are measured using Shearing bridge. AC bridges comprise Anderson and Maxwell bridges. Question: why is DC resistance for different wires measured using a Wheatstone bridge? A. To maintain a source of constant EMF. B. To calculate the effective resistance. C. Check the quality of wire. D. To calculate the power dissipated. Answer: check the quality of the wire. In the Wheatstone bridge circuit, the source of voltage remains the same and this maintains a constant EMF in the circuit. This is why DC resistance is measured in different wire materials to check their quality. Question: the resistance range measured by the Wheatstone bridge is A. 10 k ohms to a few mega ohms. B. 100 ohms to a few tera ohms. C. 1 ohms to a few mega ohms. D. 100 mega ohms to a few giga ohms. Answer: 1 ohms to a few mega ohms. Wheatstone bridge is typically employed to measure medium resistance and not lower resistance ranges. Thus the measurement range varies from 1 ohms to a few mega ohms. Question: what is the cost of maintenance of a Wheatstone bridge? A. Expensive. B. Low. C. Source EMF dependent. D. Component dependent. Answer: expensive. The maintenance cost of a Wheatstone bridge is extremely high owing to its resistance tolerance limit of up to 1%. The source of voltage or the components do not add up to the expenses as they are typically uniform for all bridge circuits. Question: what is the effect of galvanometer in measuring high resistance? A. Dependent on the source EMF. B. It becomes insensitive to imbalances in the circuit. C. 0. D. Dependent on the galvanometer type. Answer: it becomes insensitive to imbalances in the circuit. When high resistance is measured using a Wheatstone bridge, the galvanometer can't sense such high resistance values and fails to detect an imbalance in the circuit. Question: what does the following figure indicate about the circuit? A. It is a high resistance construction. B. It is a medium resistance construction. C. It is a low resistance construction. D. It is an extremely low resistance construction. Answer: it is a low resistance construction. The ammeter A measures the current passing through the electric circuit. The voltmeter V measures the voltage. Thus, the above construction is meant for low resistances. Question: what is not a source of error in the low resistance measurement? A. The thermal EMF. B. The effect of temperature. C. The power dissipated through the electrical circuit. D. The drop in contact resistance at the leads. Answer: the thermal EMF. The current flowing through a low resistance circuit is always low. This causes a drop in voltage across the terminals, thereby nullifying the contact and lead resistances. The high current flow induces a temperature increase, causing a thermal EMF to occur. Question: if the source and the detector are interchanged in a Wheatstone bridge, then the balance condition becomes A. Reduced to half. B. Independent of the source or detector type. C. Remains the same. D. More by a factor of 2. Answer: independent of the source or detector type. The equation of a balanced Wheatstone bridge is PR equals QS. A. True. B. False. Answer: true. How many resistances are used in a Wheatstone bridge? A. 3. B. 4. C. 5. D. 6. Answer: 4. Which instrument is used as the null detector in the Wheatstone bridge? A. Voltmeter. B. Ammeter. C. Galvanometer. D. Multimeter. Answer: galvanometer. A galvanometer is used as the null detector in a Wheatstone bridge. The null point means the situation in which no current flows through the circuit. The galvanometer is used for measuring the current and also to determine the voltage between any 2 points of the circuit. Galvanometer is used due to its sensitivity and therefore, even small currents can be measured. Identify the definition of sensitivity of a galvanometer from the following. A. Ratio of unit change in unknown resistance to the deflection in the galvanometer. B. Ratio of unit change in unknown resistance to twice the deflection in the galvanometer. C. Ratio of deflection in the galvanometer to the unit change in unknown resistance. D. Ratio of deflection in the galvanometer to half the unit change in unknown resistance. Answer: ratio of unit change in unknown resistance to the deflection in the galvanometer. Sensitivity of a galvanometer is defined as ratio of deflection in the galvanometer to the unit change in unknown resistance. Sensitivity of a galvanometer can be increased by increasing the number of turns, increasing the area of the coil, or using a strong magnet. What is the principle behind the Wheatstone bridge? A. Kirchhoff's law. B. Ohm's law. C. Conservation of energy. D. Conservation of charge. Answer: Ohm's law. Find the false statement. A. Wheatstone bridge is analogous to a simple lever system. B. A galvanometer with low resistance in series is an ammeter. C. Wheatstone bridge cannot be used for precision measurement because of the error introduced in contact resistance. D. Wheatstone bridge is susceptible to high DC current. Answer: Wheatstone bridge cannot be used for precision measurement because of the error introduced in contact resistance. The false statement is Wheatstone bridge is susceptible to high DC current. It is actually not susceptible to high DC current and can give inaccurate readings if not balanced. The Wheatstone bridge measures resistance from few ohms to mega ohms. All the other statements are valid. What is the condition for a Wheatstone bridge to be balanced? A. The ratio of resistances in one arm is equal to the ratio of resistances in the other arm. B. The sum of resistances in one arm is equal to the sum of resistances in the other arm. C. The product of resistances in one arm is equal to the product of resistances in the other arm. D. The difference of resistances in one arm is equal to the difference of resistances in the other arm. Answer: the product of resistances in one arm is equal to the product of resistances in the other arm. What happens to the galvanometer when the Wheatstone bridge is balanced? A. It shows maximum deflection. B. It shows no deflection. C. It shows half the maximum deflection. D. It shows minimum deflection. Answer: it shows no deflection. What is the purpose of using a Wheatstone bridge? A. To measure the resistance of a single resistor. B. To compare the resistances of two resistors. C. To measure the current in a circuit. D. To measure the voltage across a resistor. Answer: to compare the resistances of two resistors. Which of the following statements about the Wheatstone bridge is true? A. It is used to measure voltage directly. B. It is used to measure current directly. C. It is used to measure resistance directly. D. It is used to measure power directly. Answer: it is used to measure resistance directly. Question and answers. What is Wheatstone bridge? Wheatstone bridge, also known as the resistance bridge, calculates the unknown resistance by balancing two legs of the bridge circuit. One leg includes the component of unknown resistance. What is the Wheatstone bridge principle? The Wheatstone bridge works on the principle of null deflection, that is, the ratio of their resistances are equal and no current flows through the circuit. When is the Wheatstone bridge balanced? A Wheatstone bridge is said to be in a balanced condition when no current flows through the galvanometer. This condition can be achieved by adjusting the known resistance and variable resistance. When is the Wheatstone bridge said to be unbalanced? Under normal conditions, the bridge is in an unbalanced condition where current flows through the galvanometer. What are the limitations of Wheatstone bridge? For low resistance measurement, the resistance of the leads and contacts becomes significant and introduces an error. Thank you for watching. Make sure you like this video and share it with your friends and classmates. If you are new here, do subscribe to the channel and press on the bell icon to get notifications of new videos.